time to build one of the handiest tools that the tombstone maker can possibly have, the hot wire foam cutter. If you're interested in tombstones, and you've already been interested in tombstones before this video, chances are you've gone online looking for these things, and you've seen the plethora of stuff that's out there. Hello, I am the older, wiser, far more dashing and infinitely more greenlit version of the fellow you've just been watching in that video. And in that scene before I edited it, I was about to stick my foot straight in my mouth as I uttered a whole bunch of falsehoods about commercially available hot wire foam cutters. During the course of the video, I contacted the folks over at hotwirefoamfactory.com to ask them permission if I could drop their name as a source of commercially available hot wire cutting tools. And they were good enough to send me a few ones for free to demonstrate to all of you what's going on. So if for any reason you would like to see some of the commercially available items without building your own or with building your own, give a click to the link that I will no doubt be putting inside this description. I will now continue with the video minus the blatant falsehoods I otherwise stated, and we'll continue on building the power source for our cutter. So we're going to build one from simple parts you can find in your home. Can't believe I just said that. Alright. But fundamentally what we're constructing is a more industrial, outlet-powered version of one of these things. This is the commercially available Wonder Cutter or Styro Cutter. What it is a couple of D-cell batteries inside a stock, a curving metal armature here, which connects the positive and negative terminals through a length of resistance wire. And when this unit is activated by connecting the circuit, the resistance wire resists the flow of electrons through it and consequently heats up. So you can take a piece of foam and just go right through. Eventually. With a nice clean cut. Now you could do a whole tombstone with one of these, no problem. But if you do large sections like I do, I just like a bigger, more powerful unit. So that's what we're going to build today. There's really two parts to the unit. There's your nice big setup with the arm and the resistance wire length, which I'm going to show you later, and the power source. And all the rest of the materials and stuff. But starting off, when I first started researching this, it was painstaking. What size power source should I get? How thick should the wire be? And you go online, and there's tons of wonderful calculators out there that say, if you use this length of wire that's this thick, then you need this much current, and I started going nuts. And, you know, you need this kind of transformer to supply this amount of current. You can use a hot model train transformer, and I bought one that didn't work very well because it wasn't enough power. And then I went to my joyful place of work where there is a transformer. There is a monstrous transformer. Literally, it ate like 3 kids, I swear to God. And I tried using that thing, and my wire all but melted before I frantically ripped the plug out of the wall to stop it. It was so powerful. It was So what you're after when you build this is something that's a little too powerful that you can control very easily. My choice of a little too powerful is this. This is a Radio Shack 25.2 volts alternating current, 25.2 VAC, 2 amp power transformer. Yeah. Really? But there's that. I will try to get a close-up shot because I'm over here and I'm not going to throw this at the camera. No, I'm really not because I don't want to break it. So, transformer. 25.2 volts, 2 amp. Nichrome wire, also known as resistance wire. 30 gauge. Okay, you can make a very, very decently long length of this stuff to make a big old cutter, and it will still heat up. If it gets too thick, it takes more power to put through it to use the heat. So use 30 gauge, thin resistance wire, also known again as nichrome wire for nickel chromium. You're going to want a dimmer switch. This one was Walmart, $8.95 or so. This is a push-on, push-off lighted dimmer. My system is just put on a slab of wood. In the making of this whole thing, I am going to build a system that is somewhat more shop with children, family, home friendly, that's got a few more safety features than just this. I'm incredibly comfortable with electricity and not frying myself. Other people might not be. And along those lines, I should mention, these transformers do have enough current in them to severely injure you. Do not take this lightly. It's almost like having a gun in the house. There are some folks out there, when there's a gun in the house, go, "Hey, it's a gun! I can put big holes inside!" And there are people who go, "That is a thing that can possibly hurt me. I should understand it before I attempt to use it. I should try to figure out how it's going to work before I just go, jab a goddamn fork in a light socket or something." But yeah, treat this with the utmost respect, because this transformer has the power to do you some serious harm. Don't be stupid. Incidentally, let me put just a little caveat of vocabulary on the building of one of these units. If you don't know what it is to ground an electrical system, if you're not aware of the difference between alternating current and direct current, go Google that stuff before you even try any of this, because you're not going to know what you're dealing with. Or just do it, but don't blame me. I'm not to be blamed. Electrical scarring patterns look really cool, by the way. Alright. I'm going to be trying to put all my stuff inside a little dollar store piece of Tupperware housing where it is insulated and hopefully easily kept away from, idiots. You're going to want some electrical tools for this. I've got my own handy dandy wire stripper, which I don't expect anybody else will have. You're going to want a pair of wire cutters. This is the more standard household wire stripper and crimper. I would recommend having some alligator clips handy. They make putting everything together. An alligator clip is just one of these little clips here that you can open and shut and pinch. Let's see if I can extract it from its handy insulated housing here. Yeah. This is a little alligator clip. Nom 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 nom. Yes, the nom sounds are mandatory when playing with an alligator clip. First thing we're going to worry about is extension cord. Something that's got a plug on it. And I should also continue to mention, before I jump the gun even more, that this is not a grounded system. Alright? If you want to ground it yourself, get yourself a 3-prong plug, not a 2-prong plug. I've never had any trouble with mine. Mine is not grounded either, but it's never given me problems, because the current will usually just equal itself back out. So the first thing I'm going to do is snip off the warning label, which everybody else who's not comfy with electronics should bloody well read. So this is going to be my power source wire, assuming I can hold on to it. I do not need the end piece at all. So I'm going to give myself maybe 2 feet of wire here to play with. This is a 6-foot cord. Cost me about $3-4 bucks. So I'm going to save some wire for the internals of this power source, but I do not need the plug end at all. I'm going to uncork my transformer. Alright, I hope you can all forgive the camera angle, but I thought it would be far more expeditions if everybody could actually see what the hell I was doing, rather than have it be from 5 feet away and have everything be entirely too small. So here is the transformer, which I have finally extricated from its packaging and removed the little bits they threw in there. Alright, so here we have, obviously, the transformer. Da-da-da-da-da. Transformer has 2 sides. It's got the spot where the alternating current's going in. These are 2 black wires. Positive and negative don't really make a difference here because this is alternating current. It's going back and forth in there no matter what. And then it's got its output side. 2 yellow wires and a central black wire. The current going through in a loop from the 2 middle wires is 25 volts, or 25.2 as the packaging dictates. The center here is what they call a middle tap. This cuts the coil size in half. So if I connect these 2, I'm only going to get 12 volts. I'm going to get half the voltage out of this. But for this case, the middle black one is not anything we're after. So we won't be using it. We want the full 25 volts. Or I should say the full potential for 25 volts. When I first did this, again, the problem was getting too much power at once. So the way I solved this problem was to rig a dimmer switch to the alternating current coming from the wall to control the amount of power getting to the transformer. So I didn't have to worry about it rushing in and I've got too much power, my wire heats up and it goes red hot, fizzles out, and boom. No, no thank you. So we will be using a dimmer switch to control the flow of electricity going into this system. Control really is the name of the game here. Too much power all at once, your styrofoam's going to get French fried. Too little power, it's never going to heat up enough to cut. So, control, control, control. So here's our dimmer switch. The main thing to be careful of when you shop for dimmers, some of them are set to 3 stages. You want a full range dimmer, not a 3-stage dimmer. You want the full range. I should probably also mention at this point, you're going to want a hot glue gun heating up. I am just removing the extra bits that we won't be needing for this project. Wires on the dimmer. Green is ground. This system is not grounded. If you know about grounding and you're concerned with things being a safety issue, you're going to want to ground the system using a 3-prong plug rather than a 2-prong and attach this grounding cable here to the ground. Otherwise, here are your pretty much in and out wires for the dimmer switch. Whichever one's which really isn't 100% important straight off the bat. Now, because I'm trying to make this system a little bit more family friendly, I bought a 67-cent regular light switch. This is going to serve as a safety switch. If this thing's off, the whole system has no power. It's also going to be kind of an emergency kill switch if the need arises. So we've got our 3 initial components set up. What we've got to do here is rig them all together along with our plug to get this system set up, or at least the 1/2 of this system set up. So let's begin with the plug. The plug, we cut off the end section, and what we're going to want to do now is separate these wires. Let's clear our workspace. These 2 wires correspond directly to the outlet plug. One of them is going to each tong. And then we're going to strip them down a little bit. Hopefully using the right part of the stripper. So I've stripped my wires. If obviously you don't have one of these fancy schmancy automatic strippers, then you use the standard electrical tool. It's got wire stripping sections in the centerpiece. Open it up, put your wire in, set it to the appropriate length, crimp down, and then pull it off. And that'll pull the rubber insulation away from the wire. First thing we're going to rig is our safety switch right here. One end of these two, doesn't matter which at this point, is going to go into this switch. You've got several sections. The two side screws here are the ones that are most important. One's effectively in, the other one's out. You're also going to have another one that is directly connected to the outer playing or outer facement here. This is a ground, alright? So no static charge accumulates on the faceplate. We're not going to worry about the greenest screw. Green is ground, in case you haven't picked up from both this and this. Green is ground. Alright, so we're going to take our bit of wire and we're going to twine it around one of these two screws. Doesn't honestly matter which one. Get it as tight as you can. Make sure there's no little wisps of wire sticking out. Sometimes these things have a tendency to want to brush and go out. We want to make sure all these things are together. You can help that by twisting them up into a more solid cable and then wrapping that around. I noticed that because I was just having some pain in the butt difficulties getting it done. Wire is connected. Grab yourself a screwdriver and screw it down. So far with this system, our electricity is coming in from the wall, meeting the switch. If the switch is off, it goes no further. If the switch is on, then the electricity can start coming out on the second copper plate and moving on. The second copper plate here and the second connection we're going to take to the dimmer switch. Now, earlier I cut a piece off that extension cable to use as just straight wire. I'm going to start using some of that right now. So I've got two pieces here, and just like before, I'm going to grab my cutter and I'm going to separate them. Each of these individually is a wire section. I don't need a whole lot because this is all going to be contained inside this bin, so there's not going to be huge distances involved. Now I'm going to grab myself and strip a section of wire. I'm going to give myself maybe 8 inches of wire. If it's too much, I can always cut it down later and or just tighten it up with some electrical tape. I'm going to twist this up. This is going to go on to my other screw over here. Make sure it's on. I'm going to screw it down tight. Incidentally, if you ever plug this thing in while you're building, you're a damned idiot. Just thought I'd mention that in case anyone decides to sue. Okay. Wire coming from the out in the wall. Electricity is coming through. Switch is off, gets no further. Switch is on, electricity is free to continue traveling up. Now it's going to go to the dimmer switch. Dimmer switch has two ports to it. One's going to be pretty much in, the other one's going to be out. So I'm going to take this bit here, and honestly I don't like the amount of wire there. I'm just going to increase it a little bit. I'm going to twist these two together. Fortunately, my dimmer switch came with one of these fun little end caps, and I'm going to use it. It's kind of handy. So now these two are spliced together, twisted. There's no bare wire showing. I don't really need to worry about the safety hazard here of having anybody touch this. Okay. Now we've got our transformer. And we've got the other end of our dimmer, which I'm also going to strip down a little bit more. So again, electricity coming from the wall through the switch into the dimmer. Now, dimmer controls how much electricity goes through. All of it, none of it. Dimmer also should have an on, off. So you got two safety switches on here. So moving out of the dimmer and into the transformer, one of the two prongs. Well, these will be the black connections. This is the AC, or alternating current, in. I'm not sure that this cap that came with it will work for this one. In fact, I doubt it will, but I'm going to just quickly try. That is a sweet cap right there. Yep. Good. Those are spliced together and capped. If you don't have one of these caps, you bought one that doesn't come with it, just splice that wire together by twisting them together, and then get some electrical tape and cover the hell out of that. You do not want bare wires or metal surfaces exposed, except for perhaps the tops of these light switch plates. When we're done here, I'll be covering these connections up with electrical tape because I do not want any kind of metal exposed. If I've got children or somebody who's not comfortable with electricity going, hey, what's this? Reaches in the bin while this is working, I don't want them to get shocked and kill or hurt themselves. When I say kill, I meant hurt really bad. So, just to reiterate yet again, electricity coming through the wall, through the first switch, through the dimmer, controlling how much power is in there, goes through, goes into the transformer. Transformer is going to turn this into direct current. That's going to come out this side. But then that current needs somewhere else to go through the alternating current side. So it's going to come out this wire. This wire is going to attach to the other side of the wire that's going to our plug. So this forms a loop. Wire coming in, electricity going through the switches, into the transformer, coming back out, and going back to the wall. I did not count on that being so easy. And again, if you don't have the end caps, just twist them together and wrap the snot out of them with electrical tape. No exposed wires if you can help it. Okay, that is your power source right there. Now we're going to put a power source into its container. Now, I don't want these components sliding around the container at all. So while we've been chatting here, I've been warming up my hot glue gun. One other thing I'm going to do is, this transformer kind of worries me. There's only a small base at the bottom for me to glue up, so I'm going to attach it to this piece of wood after I quickly make sure that will fit in the bin and still be able to close. Yeah, that really should not be a problem at all. Earlier I picked two little screws out of my spare parts bin. And I'm going to attach this transformer to it. Now to decide how I want this in here. I'm definitely going to want this on one side. I'm probably going to want these two available going out one side. My dimmer control is going to be in the center. If I wanted to be really slick, I could probably put it in the lid without too much trouble. That could be kind of neat. I think I'm going to go for it. I think I'm going to hide my safety switch on the side just to be ultra secure. And I'm going to have my power line coming out one of these parts on the bottom. So first I'm going to cut myself a hole on the side for my power to go. That wanted to break far more than it wanted to cut, so I'm going to be careful here. So I'm going to thread my plug out through the side. I'm going to make sure that these side plates of my switch here, which have exposed wiring metal, get covered up by electrical tape. Like I said before, I want to put my safety switch on the side, so I'm going to cut a spot for it. Hoping I don't have a repeat of that last little breaking incident. This is a unexpectedly sturdy piece of Tupperware here for a dollar store purchase. Okay. There's my side safety switch. I'm just going to take a second to hot glue that in there. So here's my safety switch. This on or off, this thing can or can't work straight up. This is the first spot the electricity is going to go to in this system. One flick of that will kill it immediately. As I said before, I don't want my transformer sliding around this box, so a little bit more hot glue on this nice broad wooden surface should stop that from ever happening. Alright, now that's not going to slide around anymore. I got a little bit of wobble from the screws, but otherwise we're in good shape. Alright, do I want the dimmer switch mounted to the lid? That would look really snazzy. It might also be a little bit wobbly, but this plate's really flat. I'm going to go for it. What the hell? That way I can be assured that nobody's ever opening this up to get to anything that isn't needed. Alright, once I shut this lid with that though, it's probably going to be the last time I need to get in there. So the other thing I'm going to do is I'm going to make a spot on the side for my two wires coming out of the opposite side of the transformer. I'm going to take this middle tap black wire and I'm going to tape it up. Here's my two dangerous prongs. These guys right here. I'm going to want them coming out this side. I need to be able to access these. When I rig this up to my resistance wire, the resistance wire needs to have electricity flowing back and forth between these 2 points. So I'm just going to bore myself a little hole in the side for each of these, and I'm going to keep them relatively far apart because I don't want these wires ever to be in danger of touching one another. These transformers have a safety measure inside where if the current goes way too much, an internal spark gap will go and allow this to discharge. But I don't want these guys ever in a position where they're readily, easily, and able to cross. So here's my 2 holes. Out from one. Out from the other. These are going to be your 2 most dangerous parts right here. So I would advise having some measure to cap them, seal them, control them, make sure they don't go wandering all over the place, make sure they don't come into contact with anybody. These are going to be your dangerous bits. As to the rest, I'm going to hot glue this thing here to my lid. Grounding wire here is not dangerous. No current's going to be going through this. I just totally burned my hand on that hot glue. Wow! Hot glue is hot, as I tell many students all year long, and then I screw it up myself on a YouTube video. Okay, so this grounding wire is not dangerous. I am not using it. Again, if you want to ground your system, this is what goes on the 3rd prong of the plug. There's the 2 alternate current, then there's the grounding prong. That's what would go to this. So, FYI. But since I'm not using it, I'm just going to tape it up. And I'm going to glue it to the inside here. Do a quick double check. Make sure there are no exposed wires in here. Nothing's touching from any electrical sources. This is all wires. These are capped. These are insulated. Nothing's moving around. Now I can go ahead my power source is pretty much set for my hot wire cutter. It's nice. It's insulated in plastic. The only thing I'm going to do is I'm going to just put a little hot glue around these 2 wires here. Make sure they don't go anywhere. And this will provide me with current that I can control. I am not destined and obligated to use the full power of the transformer. It goes through my dimmer switch. So my dimmer switch controls the amount of electricity that gets through there. The next thing you're absolutely going to want to do is label this thing. Anybody who's having trouble using it for the first time, is having any kind of issues with it whatsoever, is going to need to know, there we go, what's going on. You yourself are going to want to label which way to twist your dimmer. Which one's high, which one's low. You're going to know that very soon after you plug it in and test it for the first time. Safety, off, on. Danger, don't be stupid. Shock hazard. Make sure everybody knows this thing is dangerous. So here is the power supply for your hot wire cutter. And again, combined parts cost right around 30 bucks. So what we're going to do is briefly test it to make sure it's working and working correctly. And I haven't just spent the last God knows how long here putting together this little video in absolute vain. And then we're going to actually build the cutter ourselves. And not just the cutter. Once you have the idea of the cutter down, you'll be able to build a wide variety of cutting tools fit to your own specifications.